All right, we're going to go ahead and get started here. How's everybody doing today? First day of Drupal camp. Okay, I'm going home. Still so we can count. All right, I'm going to go ahead and get started here. This is Introduction to Object-Oriented Programming. How many folks in here would consider themselves novice in terms of programming? Okay. No shame in that. How many people would consider themselves experts in programming? Oh, come on.
In what language?
Doesn't matter, any language. Okay. So if I have questions, I'm asking you. Or you. All right, so we're going to go ahead and get started here. I'm Will Long. I'm a Drupal consultant based out of the Chicago area. I'm primarily focused on back-end development. Subject-oriented business is very pertinent to what I'm doing, especially now that we're getting into Drupal 8. I do a lot of work with different agencies, do a lot of work with Breakthrough lately. One of the things I like to do is help people get their development workflows improved, help out with things like continuous integration, test coverage, things like that. Some more things that I do is I like to work with end clients, particularly to help them work with their vendors to get the most out of them. So if you're looking for things like that, come talk to me. So the objectives of this sessions are twofold. One, understand the basic object-oriented programming concepts. So think of this like you're learning another language. I'm going to teach you to find the restroom and order a quesadilla. So hopefully that'll get you on your way. And then additionally, we're going to cover some ways we can use object-oriented programming to customize what Drupal does for us. So the way we're going to do this is we're first going to look at some various styles of programming, so we can see kind of the history of what's got us to object-oriented programming and object-oriented programming in Drupal. Take a look at the classic object-oriented education materials, just the fundamentals of object-oriented programming and how PHP does that. And then we're going to look at the real-world Drupal examples of using object-oriented programming. So, what's your programming style? Did anybody recognize this screen right here? This is the Commodore 64 implementation of BASIC. Now, this is how I learned to program way back when. And I don't know that instructional programming is actually a term. I kind of made it up. But basically what I'm referring to is the notion of just taking commands, putting one right after the other, and running your program from start to finish. So, I mean, what you can see here, this is inputting somebody's name, replying back hi, asking how you are. It doesn't care how you are, but it asks. And then it says, nice to meet you. So this is a very natural way to learn programming. It's just a series of commands that runs from start to finish. A lot of ways, it's very synonymous with a web application, particularly one written in PHP. So PHP was initially written as a templating language. So we start out with generally what looks like an HTML file, and then we extract little bits of that, and in place of it put in dynamic pieces of data that are generated by PHP. So you could, for instance, put the time in there. If you happen to collect their name somewhere along the way, you could put their name in the middle of the page, different things like that. So that's a lot how PHP started. Just once again, start to finish, we have a series of commands, run them, and we're done. That kind of evolved into what is known as procedural programming. So here we take the actual commands that we're running, and we're going to group them into coherent functions or subroutines based on what language you're in. So here we've got essentially the same program that we just saw, but it only really uses two things here. So we get the name, and then we display the name back. So instead of having that series of commands, the actual program is simplified into two distinct pieces that are responsible, once again, for getting the name or displaying the name. So here's just the index.php at Drupal 7. I don't see any object-oriented programming in here. This is very much procedural. Once again, this is the entire Drupal application at the most abstract level. We set a constant, we load in the code that contains all the bootstrap functions, we do the bootstrap, and then we send Drupal off into some obscure method inside of the menu functionality to actually service the request. So this is an instance of procedural programming. So Drupal 8 is, once again, very similar in nature. It does a lot of the same things here, except there are small bits of object-oriented programming in here, which we'll cover later. But essentially, it's doing the same thing. It auto-loads some code that it needs to get started. We start up a new Drupal, and then we run a couple commands on it, which tell Drupal to service the request. And then another note regarding this, when I was doing some research on this, I watched Lorna Jane Mitchell's session she did at DrupalCon Amsterdam, and she said this phrase, which kind of stuck with me. So we do not need objects to create great things. So a lot of things have been built not using object-oriented programming. All Drupals up until now pretty much do that. Drupal 7 has object-oriented programming, but not a tremendous amount of it. But that's one thing to keep in mind. Not everybody loves object-oriented programming. Hopefully today we'll cover how to get the most out of it. It's here for Drupal. It's not really going anywhere. And if you have some free time on your hands, I actually encourage you to watch there's a couple of YouTube videos by a gentleman named Brian Will. And he has some interesting takes on object-oriented programming, why it's not so good in his perspective. And he takes a couple examples of different object-oriented sessions that have been presented and critiques them and shows how and why it would be better to not do those in object-oriented type style. All right, so we're going to dive into the actual guts of working with object-oriented programming in PHP. So the examples we're going to use here are all kind of going to be based off of building an application that deals with forms. So in this example, we've got a text field. Don't confuse this with Drupal's actual text field. It's very closely tied with the rendering mechanism. So this is not Drupal's code here. This is just some simple code that I wrote. Also, don't use this anywhere. It's not particularly secure, particularly just reading right out of this post variable. But the idea here is that a class is just a codified example of a real-world object. So our real-world object is that text field in the form. It's got certain things about it that we do with it or do to it, and there's certain data that it provides back to us. So here we've got a couple things to keep in mind here. Regarding object-oriented programming, we've got this variable that sits inside of the text field class. This is a property in object-oriented lingo. We've got 3 functions that live inside of the class. These are called methods in object-oriented lingo. And this first method is special because it's the constructor. So when we go to actually create it, that's the code that's going to get used to start up our object. So in this case, we pass it a name, and then it's going to save it in its internal variable to the class here, and that'll get used throughout the lifetime of this class. So when we actually go to use a class, we want to create a text field, right? So we want to create an instance of this text field. We instantiate it. So we get a text field. This is an example of how we would do that. So we would say this is the variable we're going to put it into, create a new text field, and the name property will be set to first_name. In the example here, we can also set the name property to anything we want to. Say we started with the wrong one, we can give it a new one. And then we can also interact with methods on this object by calling them with this type of syntax here, field, arrow, get value. And in that example, it would give us back the post value of fname as submitted to a form. Any questions? So one thing that was in our example there, the property methods were all declared as public. So I just want to cover visibility real quick. One of the useful things about object-oriented programming is we can actually hide properties or methods in the class. If they're in the property, we can make sure that the outside doesn't use them. If we want the outside to have access to them, we do public. If we want the outside to have no access to them, we would do either protected or private. Those do two separate things here. They're kind of similar. Protected means that other classes that extend that class can also access it. We will discuss inheritance and extending classes in just a little bit. Private means only that class can see it at all. One further thing to keep in mind is a method may be declared as final, meaning that it can't be overridden at some point later. All right, so we have our text field object, but at some point, to make this a useful example, we're going to want to have a whole bunch of these different classes, right? So we're going to have different things here. We've got our text field. We're going to want checkboxes, radios, drop down, select box, all sorts of different things. So this is where object-oriented programming really starts becoming useful. You can see the different types of form elements. This is some that Drupal has, for example. So things we didn't even discuss, a password element. You've got hidden elements in your form, and some HTML5 type elements, email, telephone, and don't forget about our submit button. So to some degree, these elements are all very similar in nature, right? So just take, for instance, how we're rendering them. Each one's got a label. We've got the actual element. Got a description. So they all kind of do the same thing. So wouldn't it make sense to consolidate the functionality of those? There's a couple things to keep in mind here. So first off, we probably want to do this through an interface. So this is going to be a consistent interface for all of our form objects. So in this case, the different types of methods we could have, we'd have a constructor, so they would all take the same arguments when we go to create any form element. Maybe we need some function to check if that field is required. So we go through to validate the form submission. If any of the required ones are required but not present, we have to throw an error. The get value function we saw earlier, and also we have to be able to render it into a form. So this is a pretty standard interface we would have for our form elements. So one thing we want to do is we want to code to that interface. So here's an instance of actually creating a form using those objects. So say we've got an array of elements. So we've instantiated all of these objects into an array. We want to actually make our form now. So we're just going to iterate over the form, each element in the form, and call its render functionality. So by doing that, form will then be a string, which we can then output onto the page to get our entire form. So one of the most useful features of object-oriented programming is the notion of inheritance or extending classes, just being able to consolidate functionality, not repeating ourselves on various different form elements. So the idea of inheritance is the parent class defines different properties and methods that apply to all form elements, and then the child class would then inherit all of those. So even if we had our form element class, so say we've got a form element base class that has all those common pieces of functionality, it might have the constructor in it where we assign the name variable. The text field, select list, and submit classes wouldn't need that. They would inherit that automatically. They would only need to implement methods that they need to do whatever customizations are necessary for that form element. So here's the case of extending classes, code version of that. So we've got our base class here. One thing to notice is that this is just declared as abstract, meaning you can't actually instantiate it. It's a template for the child classes. And it's got the constructor, it's got the get value, it's going to have any other pieces of code that are common to the children. And then the two children classes, we've got a text field class and a text area class. They're almost identical in nature. The only things that are really different from them is the actual markup that represents them. So we can see the text field is going to, in its render method, output an input tag with the appropriate attributes inside of it. Same thing with the text area. It's going to, instead of an input, it's going to output a text area with the name and the value. The previous example was a pretty simple example, but we can do a lot more complicated things with it. So say we've got our form element base, we've got our text field underneath it. We could also have a whole different segment of types of form elements, say form options elements, our select lists, checkboxes, radios, things like that, things where we have a list of options that we're selecting one or more of. And then on the other side, we can see the text field. Maybe we want to have a special text field that has some AJAX autocomplete type of action going on. We can do that pretty easily just by extending the proper classes. One of the things that we kind of mentioned briefly but didn't really dive into is the notion of overriding methods. So in this case, the parent class defines the method. The child class will actually override it and use its own implementation to do some type of customization to that method. So in this case, we're going to look at that AJAX text field that gives us the auto-suggest. In this case, all we would probably really be doing is adding some JavaScript into the page to do the autocomplete suggestions. So in its render function, we would just add that JavaScript, and then from there, call the render function from the text field that it is extending. Does that make sense? One thing to note here is this parent keyword. That refers to the class that's being extended, which is the text field, so we're literally calling the render mechanism from the text field. So not really directly related to extending of classes, but one piece of object-oriented programming that a lot of languages support is overloading. It's not a feature of PHP. So overloading is when you have a function declared multiple times, and it accepts either a different number or different types of arguments. PHP doesn't do this. It's technically possible by doing some logic inside of your method and figuring out what types of arguments were supplied, and then from there doing some type of conditional execution of some more code. But it's really just complicates things. So I suggest keeping it simple. Just create it. If you need to accept different arguments, just create a different method and let it do the same thing. One other thing that PHP doesn't support is multiple inheritance. Some languages do this. I believe most of them do not. So in this case, say we've got our AJAX text field and we wanted to implement things from two different parents. It's really not possible. So you've got to pick one and go with it. There's some techniques you can go to not really implement multiple inheritance, but to to take advantage of some not repeating of your code, particularly by passing in any functionality that's needed by dependency or things like that. Yes?
In order to share functionality as well, you can use traits.
Right. One thing you're going to need to know to work with object-oriented programming in Drupal 8 is namespaces. So namespace is essentially just a prefix to the class name. So here we've got this is actual Drupal 8 code right here. So we've got our text field, and it actually lives inside of Drupal core render element. So whenever you go to refer to this, you need to use this entire namespace name and the class name to use this field. One other thing to note here is we're using this use keyword. That's actually how you can simplify this. So if we wanted to use this text field, we could, in our own code, have use Drupal core render element text field, and then we could refer to it as just text field. So it's just a way to avoid collisions with classes with the same names, organize our code. We'll see some more namespaces later when we look at Drupal 8 code. So here is the traits that we just mentioned. I actually generally suggest avoiding traits. This example, I think, is actually a really good example of a good use of traits. So this is some Symfony code, actually, that we're using here. It looks like a class. It essentially is a class. You just can't fire it up and use it like a class. It gets used inside of another class. So here we've got a protected property and a public function. And so it almost looks like an interface, but it's not an interface because we've got functional code here inside of the setContainer method. So what will actually happen with this is this, think of it just like this code is going to end up getting copied and pasted into any class that uses that trait. And to actually use the trait, very similar to some code we've already seen. So this class, the class resolver, uses that container aware trait that we just saw. And so it essentially now contains the setContainer. And then other code in that class can use the container property. All right, so make sure everybody's awake. Let's, somebody, anybody, please yell out what these actually are. The class, what's the class?
A group of methods?
And properties to help you define an object.
Right. So the thing that I like is it's the template. So it's the code that will eventually become your object. Right. So it's the code that represents what your object will be once you instantiate it. Inside of your class, you have two things: properties and methods. All right. Property is a variable, method is a function. Those properties and methods have visibility. Does anybody remember what the visibilities are?
Public,
Protected, private.
final, and
Restricted.
It's public, private, protected, and then for the methods, they can be declared as final. They can also be declared as static, which is different and is a little bit beyond the scope of what we're talking about right here. But think of static as just a function that can be called outside of the class. So if we have a bunch of classes that we want to interact with all in the same way, we give them all a standard type of interface. I'm making it really easy. Come on. All right, and if we want to have a hierarchy of these different classes, one is going to inherit from the other. That is called
Inheritance.
inheritance. Awesome. Child classes can do what to parent classes?
Overriding.
Doesn't that happen a lot
Overriding.
with toddlers, right? And then some of the more sophisticated stuff. Later version of PHP, we've got the namespaces and the traits. All right, so a couple more kind of advanced notions. These really aren't that advanced. They just seem to kind of sound advanced if you don't know what they are, if you're not familiar with them. So dependency injection. So this is the notion of inverting control of the dependencies of your classes. So take this persistent object as an example. This is something we want to save and then presumably reload later on at some point. Here is a case of a hard-coded dependency. So right here in the constructor, we fire up a connection to our MySQL database. And then later on in our code, we're going to save it. What's wrong with this? What's one of the, I mean, it'll work, right? What's one of the deficiencies of this?
It's really hard to switch databases.
Exactly. What if we don't even want a database? What if we want to save it to a file? What if we want to put it in the user's session or cookie or something like that? We really can't do it. What if we want to run a unit test on this? Really can't do it. So the idea here is to avoid these hard-coded dependencies and to inject some type of storage interface right into the constructor. So instead of depending on the database, we're just going to depend that somewhere along the way we've been given a database. Not even a database necessarily, but we're going to call it a database. So that's really all dependency injection is. It's relinquishing control out of this persistent object and into whatever's using it, letting that provide our dependency. One other thing we're going to see in Drupal is the service container. This really isn't that sophisticated of a thing either. If you can use an array, you can use a service container. So just think of it as a bunch of key value pairs. Each service has a name, a string name, that refers to what it is. And on the other end of that could be anything pretty much, just whatever the service is. So you'll see this get used in Drupal a few different ways. Modules will declare their services in their YAML file. A lot of times that's just telling it what class to fire up and some parameters to use as that service. And then when we actually want to use it throughout the process of rendering a page, some code like this will give us the service. Related to the dependency injection we were just talking about, we don't want to call it directly in classes. We want to avoid that whenever we can, and pass that dependency as a parameter. It's a nice page on Drupal.org, kind of discussing service container and different usages of it. All right, objects in Drupal 7, like the Yeti. It's out there somewhere. Some of us have seen it. So when we're working with our objects, one of the things that we want to have to deal with is auto-loading it. We don't want to just require it or include it in our code on every single page request. So here we're looking at the core system modules.info file. So to auto-load your classes in Drupal 7, all you need to do is add a line to the files. So here you can see the system module has several classes that it declares. The standard convention is to put them in a file that ends with .inc. You can put one class in there, you can put a whole bunch of classes in there, probably your interfaces in there, whatever you want. I prefer to separate them all, but it's feasible, and there are lots of cases where they will be combined. And then we also got a test file down here. So what do you think is probably the biggest usage of object-oriented programming in Drupal 7?
Migrate?
Views. Views.
Views is a big one, but it's not core 7, right?
Oh.
No, but there's a ton of views in there. We'll look at that also, but particularly SimpleTest suite. So in terms of core, the SimpleTest suite is just essentially all object-oriented programming. Migrate has some as well. I think the scope of it is probably significantly less than views, though. So in this case, we're going to use our object-oriented programming skills we just learned to deal with simple testing. So here we extend the Drupal web test case. It's for an integration test. So that will actually fire up a Drupal, clean Drupal using the testing profile. And then from there, we can do all sorts of things, mimicking a browser interacting with Drupal, run through whatever pages, form submissions, things like that. There's also a unit test case to run unit tests. They're a lot faster. So if you're just testing code, we can run tests against code using the unit test case. One thing about this unit testing is it actually will fire Drupal, but not the database connection. So it's there's still, it's not as fast as it could be. It's not as fast as Drupal 8 is with its PHPUnit testing. So to do that, we're going to extend one of these classes. There's a couple of methods we need to implement to let Drupal know about what's going on with the test. And then any method that Drupal can find on the test or on the class that you have implemented that starts with test in all lowercase, then gets run. So the test is just a series of assertions, different steps that get run, and then the test claims that it should. The result of this assertion should be some value, true, false, and some arbitrary value. Find some string in the page, things like that, and then it'll run through the test. There's the queuing mechanism. This is a little probably abstract for this demonstration, but in this case, Drupal's got a core queuing mechanism that lives in the database. So various things, put things in the queue on a cron run. It processes items out of that queue. There's actually several implementations of this within core. There's the system queue, which we were just discussing, that lives in the database, and there's also a memory queue, which is not reliable, which is interesting. Not reliable meaning the execution of the queue items may not happen in any particular order. But in this case, if we wanted to add our own queuing behavior to this, we could create a class in our module, put it in our .info file so Drupal sees it, and then there are a series of variables that we could set to make Drupal aware of this. It'll see this as it goes to process the queues. You could do a specific queue by setting the variable like this, or you could do one of the other variables and it'll process all of your queues using your custom class. Some additional object-oriented programming cores, your entity controllers, nodes, users, and comments have their own entity controllers, I believe. The Entity API module has a default entity controller that's pretty useful. So if you're going to implement your own custom entities, you'll probably end up using Entity API. It does a lot of convenient things for you. But even then, if you need to customize the way the Entity API's controller handles things, you can create your own class, get it in your .info file so Drupal sees it, and override whatever methods you need to make it behave the way you like it to behave. The mail system. The mail system is sending out mail. Drupal's got a core one that sends out plain text emails. There's the Mind Mail module. A lot of people use that in conjunction with the mail system module to send out HTML formatted emails. The Devel module has a mail handler for testing. So if Drupal's sending out emails and it's configured to use the Devel mail handler, they'll get saved onto your disk in the temp directory somewhere where you can find them later. The search query handler, that's for the core search module. If you don't like the query that it's using to extract results out of the search index, you can write your own. So that's pretty neat. And then the module and theme updater, so the functionality of Drupal to pull down a module or theme from Drupal.org and update it on your site. That's all object-oriented based. And so we've got a module updater and a theme updater. Any idea what the parent class is?
Updater.
Updater, yes. And then one thing that already got mentioned here is the views object-oriented implementation. So one of the probably easiest wins you'll get out of object-oriented programming comes in dealing with views. So this example is for Drupal 7. The Drupal 8 example is similar in nature. Code is actually a little bit different. But what you want to do is implement hook views data or hook views data alter, depending on what you're messing with. Or from there, you define a handler for the field. You define a field handler, which is the rendering. Define sort, argument, filter handlers, things like that. Those all deal with one, creating the query, and two, rendering the result of the query. If you're messing with a table that is defined by some other module, you can use pseudo fields. So that's just in the declaration of the table to views. You add your own field in there, and then tell it that it should actually be using the real field. Does that make sense?
Kind of like an alias.
Yeah, exactly like an alias. So here's a codified example of that. So we've got a views handler field day. So we're going to extend the views handler field, which already exists and does a lot of heavy lifting. It provides the configuration form within the views interface. It will do a lot of other things. The expose filter form, different things like that. But all we really care about is getting back the value. So in this case, this would be a Unix style timestamp. So all we're going to do to make this happen is we're going to override this render method, get the actual value, and then pass it off to PHP's date function, and that's it. So that's all the code it would take to add a views handler into Drupal 7 in order to take a time, to say like your node created or node updated timestamp. We could just put the day of the week on there, just do this code like that. Not particularly useful, but feasible. Another thing we could do with it is we could add a sort handler. So in our view, we could sort by whether the date was in the past or not. So in this case, we have a Boolean result of a formula that we're going to pass off to MySQL. So it's either going to be 1 if it's in the past, or 0 if it's in the future. So here we're just going to override the query method. There's a function to ensure that the table that we're querying is added in there, because we're not actually going to query the field. We're going to query a formula, which is the value of the field is less than, this is a Drupal constant request time. So if the value of the time when it was created is less than request time, we get back a 1. Otherwise, we get back a 0, and let views in MySQL or whatever backend we're using deal with the ordering. Does that make sense? All right, object-oriented programming in Drupal 8. I think we've seen it. Autoloading. So the autoload exchange, we got rid of the one-off Drupal.info file declaration of autoloading. Here, we're going to be using the PSR4 standard for autoloading. It just has to deal with the directory structure that we use to place our files. So for example, I actually picked this up at Drupal.org. If we have a vegetable module, and it declares entity that is tomato, you can see it's going to live in our modules directory in the vegetable module, src entity tomato. So it's just a more standard unified way of the things I think a lot of people are probably already doing. One class or interface per file. The unit tests, which we discussed a little bit earlier, are similar, but they actually don't go in the src folder. They're going to go in the tests folder. Plugins. Plugins is one of the big selling points of Drupal 8. You can add our own plugins. Here are some core type plugins that are used all over the place. And actually, they're not all core. We've got actions, blocks. Those are pretty standard things we've already seen in previous versions of Drupal. They've been created as plugin objects. The form elements we were discussing, those all get built and rendered to this object-oriented structure. Image actions, cropping, resizing, things like that. Each different type of action is its own plugin. And the text filters and then views are very similar to how they were done in Drupal 7. A lot of the details are different, very similar. One of the things you'll notice about plugins is they have an annotation at the top. This Drupal does a discovery mechanism of finding all the plugins. So you create your file, put it in the right directory, put your comment at the top, Drupal will find it, start using it. So any place, if you wanted to add a filter, you would create a class, put it in the proper directory, go under plugin, filter, and then from there, Drupal will find it, and it would be available in your input formats configuration page. So what actually goes into the annotations and the methods that you need to implement in your plugin are all very subjective to the plugin type that you're creating a new plugin for. My best recommendation there is to extend a base version of the plugin. So, for instance, the filter base, I believe, is an abstract class that provides a lot of the heavy lifting that your filter plugin may need. And also take a look at the existing declarations of the annotations for information on what to put in there. Another place you're going to be using object-oriented programming is if you're doing some custom pages within Drupal. If you've got a module that provides a route and gets serviced by what used to be a page callback is now a controller. It's just an object that implements, this is actually extending the controller base. The controller base implements a few interfaces that are important for Drupal to pass the things along to the controller. This example of code is one thing I thought was interesting. You can see the dependency injection happens right here in this static function. So this controller implements, excuse me, the constructor for this, we're going to pass the form builder service from Drupal in as a dependency. And when we go to do this create function, Drupal actually calls that to create the class and then calls the appropriate method on it. So in this case, you can see the controller defines that it wants to use the form builder function from the container. So the service that is the form builder that lives in the container gets passed into this controller as it gets built. And then when the admin page, this is for the comment module, by the way, the admin page actually then uses the form builder to construct its response. SimpleTest still lives in Drupal 8, by the way. So the classes that you would extend have been namespaced to the appropriate namespacing under the SimpleTest module. It's also PSR autoloaded from the tests directory within your own code. If you're going to write SimpleTest, get info is gone. It's not an annotation, but it uses information from the comment doc lock in order to provide information about it to Drupal. And then there's some minor changes to the actual code that you would use for your various assertions and different things you do within the test. And then we've got PHPUnit is new. So within your module, the tests go in the test/src folder. You're going to extend the unit test case. So you're going to use setup to create your dependencies, and this is one of the really powerful things about object-oriented programming is it allows us to do these unit tests like this. So PHPUnit gives us this get mock functionality, which will literally create classes on the fly for us that implement different interfaces, and they can even create methods within this mock object that give back certain responses to certain inputs, things like that. So it's a very powerful thing to see it in action. And then it's kind of similar to the SimpleTest, where it just looks for methods starting with tests, does a series of assertions. So this is just essentially code testing code. It's not code testing your website, it's just code testing the code. And from there, hopefully your assertions all pass. And that is where I leave off. Anybody have questions about what we covered? Yes?
Why is Drupal using PHP object-oriented programming, not some other language?
Drupal is using PHP's object-oriented programming because it is written in PHP. I don't think there's any more sophisticated answer than that. The object-oriented features of PHP have evolved to where they're sufficient enough that we can do a lot of fairly sophisticated things with it. Particularly now that the minimum supported versions are we to 5.6 yet? 5.5 or 5.6 is the oldest version that's current at this point. That's the main reason is we're stuck with PHP unless we're going to do a major total rewrite in another language, which people talk about.
Well, there's also the conjunction with Symfony, right? Which is also included in PHP. Or is it?
Well, along the same lines, Symfony has kind of been able to happen because PHP supports more object-oriented functionality. So the architecture of Symfony, maybe 5 years ago, wasn't even possible. So it would have looked significantly different had it been written at that point. Anything else? All right, thank you.